the lecture on linear differential equation. Let's get started. We'll talk about definition of the linear differential equation. So here the definition is defined like this. A differential equation is called a linear. It must satisfy the following two conditions. The condition one is every dependent variable and its derivative involved occurs in the first degree. This is the criteria one. Every dependent variable and its derivative must occur in the first degree. This is criteria one. And the second criteria, no product of dependent variable and its derivatives could occur. This is criteria 2. So if you look this example 2 first, here y is the dependent variable, x is independent variable. If you look this entire equation, this is the differential equation. Here derivative dy by dx degree is 1. So as well as the dependent variable degree also 1. Now we can say, as per the definition of the linear differential equation, this is a linear differential equation in variable y, because y is the dependent variable. So here derivative of dy by dx is 1 as well as y degree 1. This is the linear differential equation. Similarly, if you see example number 1, you just rearrange. So divide both sides by dx, you will get here dy by dx equal to y plus tan x, which means here dy by dx power is 1, means the degree of this differential equation is 1, as well as dependent variable is y, whose power also 1. So finally we can say both are examples for linear differential equation. Now we will talk about standard forms of linear differential equation. In this lecture we will talk about only type 1 linear differential equation. There are two types of linear differential equations. The very first one is we are classifying like linear differential equation in variable y, which means y is the dependent variable. So let's begin. Our differential equation of the form like standard form dy by dx plus py equal to q. So this is called a linear differential equation in variable y. Y is the dependent variable. Here if you observe, here also degree of dy by dx is 1 and y degree is 1. So this is the linear differential equation standard form. Here we have p comma q are strictly functions of single variable x. Strictly function of x you can say, or sometimes constants also. So this is what we need to note. P comma q are functions of x or constants. This is what mentioned over here. Now once if we know this equation is a linear differential equation in y, we are going to find general solution. The general solution formula or rule is, so y times integrating factor, which is equal to integral q times integrating factor dx plus c. This is the formula to find general solution of this linear differential equation. So while finding this general solution, we required I dot f, which means integrating factor. Without integrating factor, you won't get the general solution of this linear differential equation. The formula for again integrating factor is e to the power of integration p dx. This is called integrating factor. So these are the main requirements. First you understand the standard form. This is the standard form. Here symbols you must know. P comma q are functions of x or constants. Now you can use the rule or formula to find the general solution, this one, with the help of integrating factor. Then you will get the required solutions of linear differential equation. Now this is called type 1 only. So in later lectures, we will discuss about linear differential equation in x. Now let's take some examples. This is example number 1. Solve. So he's asking like this question: x times cosine x times dy by dx plus x sin x plus cosine x multiplied by y equals to 1. If we observe with this equation with the standard form, the requirement is here the coefficient of dy by dx is 1. Second term is plus py equal to right side is q. But if you look this equation, the coefficient of dy by dx is x times cosine x. This total bracket, so a function of x multiplied by y equal to q. I told you this, supposing this is p, again this is q. So here combination, it's a function of x, it's a constant, no problem. But I have to remove x times cosine x. because I want every time the coefficient of dy by dx is 1. First, remove x times cosine x, then rearrange, so you will get the standard form of a linear equation. From there we can go for solution part. So the solution, I'll begin like this. So I can suppose this is equation number 1 directly. Suppose equation number 1. So let us here divide both side by x times cosine x. On dividing both side by x times cosine x, so here this will be cancel out, which means only you left with dy by dx. The coefficient of dy by dx is 1. Now it has become 1. Plus here there are two terms in this bracket. So divide each term with x cosine x, which means bracket open x times sine x divided by again x times cosine x. Again I have second term here. Cosine x is the numerator, denominator is x times cosine x times y equal to right side we have 1. We need to divide by again x cosine x, means 1 by x times cosine x. I hope you understand. It's a simple, so okay, division here x times cosine x, this will cancel out, divide by say this quantity by x cosine x, again cosine x by x cosine x equal to 1 divided by cosine x. Now again still we need to simplify this, x cancel out here, cosine x cancel out. Now simplifying one more step, dy by dx plus, so bracket, so we have a rule sine by cosine is tan x plus left with second term 1 by x under bracket y into that is multiplied by y equal to 1 by x times cosine x, 1 by x times cosine x. Let us mark this is equation 1. Now we can say this is a linear differential equation in variable y. How we can say means, this is y is a dependent variable, this total bracket is p, which is multiplied by y equal to q means this total rational function. So let us say here, so I can say you can compare, or I will be writing here which is a linear differential equation in y. So it's better to compare this one, since it is like dy by dx plus p times y equal to q. So the next step, comparing p comma q values. So where p equal to tan x plus 1 by x. Again we have capital Q is nothing but 1 by x times cosine x. 1 by x times cosine x. Now finding integrating factor. Integrating factor equal to e power integral p dx. This is the rule. So this is equal to e power integral p value. P value is tan x plus 1 by x dx. Because next step we need to find integrating factor. So it is the requirement for general solution. So just substitute p value and integrate with respect to x. E to the power of tan x integration is log secant x. 1 by x integration is log x. So again we need to apply the fundamental rules of logarithms. Log m plus log n, it is equal to log m times n multiply. Just compare this one. Secant x is capital M, x is n. So log m plus log n, that could be equal to log m times n, which means log. So m means, so I'll be writing here secant x multiplied by again x. Again we have a rule. So e power log a function of x, so equal to a function of x. The next step is compare e power log this total quantity of function of x is okay equals to function of x, which means this e and log will cancel out, you left with x function of x meaning. So now as per the rule I am writing here x times, this is rewriting x times secant x, or you can write secant x times x. This is same as x times secant x I have written in the next step. This is my integrating factor. Okay, this rule is very important. Without this rule you will not it will not be easy to simplify. After that, we have to be use the integrating factor in general solution. Therefore, general solution of equation 1. So I have given equation number 1. Yes. So general solution of equation 1 is y times, it's a formula or rule. You can say formula or rule. Okay. Y times integrating factor, it is equal to integral q times integrating factor dx plus integration constant c. So y times integrating factor means x times the secant x. This is my integrating factor, please recall. So integral q. What is q from equation 1? 1 by x cosine x. Already we mentioned here. So this is the one. So we need to substitute over there. Here q is 1 by x times cosine x. It is multiplied with integrating factor. X times secant x is my integrating factor dx plus integration constant c, which means this could be rearranging xy times secant x. This is equal to, if you look here, so x cancel out, we left with 1 by cosine x. 1 by cosine x means secant x multiplied by again secant x, again dx plus c. We have rules reciprocal function, it is 1 by cosine x is same as secant x, is same as secant x. The next step, x times y secant x, this is equal to integral secant x times secant x is secant square x, secant square x dx plus c. It's a direct rule. X times y secant x equal to integration of secant square x is tan x. It's a direct rule, integration rule, plus c. So what is this, which is the required general solution of 1? We can say which is the required or general solution of equation 1. This is the procedure. Similarly, we'll take one more question. If you observe this equation, solve x times dy by dx plus y equal to log x. So let us mark equation number 1. First, we need to make in standard form by dividing the coefficient of dy by dx, which means we need to remove this x. So here it is not okay for every problem. It's not the procedure. Some problems given with coefficient of dy by dx is other than 1. For some problems, okay, so the question itself in standard form. Now by that time, no, okay, there is no requirement to divide both sides by something. Here we need to divide both sides by the coefficient of dy by dx. Now dividing both sides by x. So in this case, here x will cancel out. So only you will left with the dy by dx. Again plus here we have y is there, dividing by x means I will be writing 1 by x times y equal to, we have here log x, so I will be writing here log x over x. Let us say equation 1. It is clearly linear differential equation in variable y. So we can say here it's a linear differential equation in variable y because it is of the form like dy by dx. Since I am mentioning here, since it is of the form like dy by dx plus py equal to q. So where I am writing p value. Capital P is nothing but it's 1 by x. Again we have capital Q is nothing but log x over x. Now we want to find general solution. So first we required integrating factor. Integrating factor equal to e power integration p dx. So e to the power of integral p value 1 by x dx. So this is equal to 1 by x integration, again log x, or you can use ln x. The result is same, equal to, so again apply the rule of e power log f of x is x, f of x means x. So since I applied this rule, e power log a function of x is a function of x, which means here log f of x is x. The result is x. Like that we can compare. Now this is my integrating factor. Therefore I have to be go for general solution General solution of equation 1 is rule first or formula or rule is, so y times integrating factor equal to integration q times integrating factor, this is q, integrating factor dx plus integration constant c. Y times integrating factor is only x, right side we have q is from equation 1 log x by x, log x divided by x. My integrating factor is x bracket times dx plus integration constant c. If you look here, x and x gets cancelled out. Now we're left with xy equal to only integration log x dx plus c. We have a direct rule for integration of log x. Otherwise, you can use Eilert rule. So as per Eilert, it's not a rule, it's a phrase. Using Eilert phrase also, we can differentiate with the help of integration by parts. It's not required now. Now remember, log x rule is x times integration of log x, I'm writing x times log x minus 1 plus integration constant c. We have a rule, it's integration of log x dx equal to x times log x minus 1 plus integration constant c. So finish. So we can stop over here, which is the required solution. We can say required solution means general solution. It's very, very important. General solution of equation 1. Thank you, students.